Last time we talked probability. Remind me what probability is. When I ask you to calculate the probability, what do you put in the numerator of your probability calculation?
Number of likelihood given. That's what you find out. So you have like 3 cases, and then you find out the percentage of the cards.
Okay.
I don't know how to describe that. I forgot what.
You described it very well. I'm just going to use fewer words, but it's going to mean the same exact thing. In the numerator, you put the number of times your event occurs.
Oh, yeah.
Okay, the number of times the event you're interested occurs. And the example that was given is if you're finding the probability of aces, you put the number of aces on the top. Great, well said. What do you put in the bottom? The total. The total number of things that could happen, right? So probability is the ratio of successes to the total. Okay, and that's always going to be true. So where we're going to start today is there is another ratio that you sometimes hear about. You hear about it a lot in sports and in the betting context, but it does have other applications. And it's what's called odds. Okay, it's a different ratio. Okay, it's calculating the likelihood of something happening, but using a different ratio. Instead of, okay, so just I want this distinction clear. Probability is the ratio of successes, the success of your event, to the total number of things that can happen. Okay, so odds, there's 2 types of odds ratios. There are the odds against something happening. So instead of the ratio of successes to total, the odds against is the ratio of the probability that something fails to happen divided by the probability that you have success. So instead of breaking the ratio up into success divided by total, the odds against break the ratio up into failures related to successes. Okay, so there's no total here this time. Okay, it's broken up into failures and successes. We can flip that ratio over and you can talk about what's called the odds in favor. Okay, so the odds in favor is the probability of failure. Oh, no, it's not. I'm just copying down what I already have. That's good teaching right there. The probability of success to the probability of failure.
How do we know what is what, like the probability of success or probability of failure?
That's a great question. That's what we're going to talk about here in just a minute. So I love it. You're just beating me to the punch. Okay, so that's great. So the question was, how do we know what success and what failure is? Well, that just depends on what you're asked. So here is a quick question or a quick example. We are going to roll a die. And here's what I want to do. We are going to find the odds against rolling a 4. Nice, relaxing example. Rolling a die doesn't have a whole lot of outcomes, so we can go ahead and do this. So we're going to roll a die. We're going to find the odds against rolling a 4. So now last time we talked about probability. So just real quick, before we do the odds, let's do the probability. What's the probability that I do roll a 4? So now odds, we're thinking back to last time. What's the probability I roll a 4? Well, how many 4s are there? 1 out of 6. There you go. That's the probability. Success divided by total. So now I want to know the odds against. The odds against, odds is a different ratio. Okay, the odds against is the probability that my event fails to happen divided by the probability that it succeeds or success. Use a different form of the word. Sorry. Okay, go ahead. What?
So instead of it being 1 over 6, it would be 6 over 1?
No, because 6 over 1 would be total over successes, and I don't have a total here. So that's a good thought. I'm glad you're thinking ahead. You're hypothesizing. Nothing wrong with that at all. So let's do this. Probably a failure. So if my success is rolling a 4, so the question was, how do I know what success is? Well, success is what you're looking for here. Success will be rolling a 4. What's the probability that I fail to roll a 4? So how many non-4s are there? Out of? And then how many successes are there? We just did this a moment ago. 1 out of 6. Yeah, we're going to simplify this in just a sec. And simplifying fraction division is not too big of a deal. Does anyone remember from arithmetic how you divide 2 fractions? You multiply by the reciprocal, which you flip it. Yes, that's right. So we're going to take the 5 over 6. You leave the top one. Times. We're going to flip the bottom one. It becomes 6 over 1. So there is a 6 over 1 in there, but that's just the result of the division. And then the nice thing about when we do our odds, your denominators are going to be the same. And so my 6's are going to cancel. So here are the odds. The odds are 5 to 1. So that means I have 5, the ratio is 5 failures for every 1 success. In odds, you would keep the 1 in the denominator. Okay, I know that normally when we're working with numbers, we wouldn't, but we want a ratio. We're expressing a ratio of the number of times I fail versus the number of times I succeed. So that's 5 to 1. And because of that, because we're not usually accustomed to writing a 1 in the denominator, odds tend to be written this way, a 5 with a colon to 1. So this would be 5 failures for every 1 success. And that's what this odds ratio is communicating to you. So again, probability last time was the ratio of successes to the total. Odds against is failures to successes, okay? That's the difference. Yes?
How are we going to have to position what the homework? Are we going to do the fraction on that?
That is a great question. I've never entered a problem into the homework. I'm guessing it's going to be the colon.
Because on the homework for the first lesson, it doesn't let you do the decimal.
It only does that, it says integer, but then it makes you do a fraction.
Okay, so unfortunately, now you've helped me. Next semester that I do this, I'll be able to tell class that, because so you have to do the fraction. I am guessing that they're going to want the colon, but you know what? If we have time before, when we do our stuff, we'll log in and we'll see, and we'll get that taken care of. Yeah.
For the probably or whatever, do we have to do those in the fraction thing? Because when I looked at it, I was like, okay, there's options, and then only one of them can succeed, and then I think you fail, so I just said like 5 over 1. I couldn't do that, like, do you have to like break it down?
No, you can do that. There's 2 reasons I'm showing you this. Okay, I'm showing you it this way because I'm relating it to probability that we've already talked about, so it helps us reinforce that. But then, for instance, there's a problem that I'll replicate on here where you're not given the event, you're given like a pie chart and you're given the percents. And in that case, you would put the decimals over each other and divide it out that way. So it would be a little, but your mindset is perfectly right. If you can make that leap, that in this situation, there's 6 things that can happen and 5 of them are going to be failures and 1's going to be a success, you can skip this and you can go right to there. That's great. Okay, so that's the pattern. And I usually at the end of this, but you've just helped me talk about it quicker. I usually at the end say, once you see the pattern for most of the problems you're going to encounter, you can go ahead and skip the busy work in the middle. Yeah, no problem. So let's go to cards, just because it gives us some extra things to do. And I've got an example for you. So we're going to pick a card from the standard deck. I'm not going to write that. We're going to pick a card. And let's just keep with this first example, be nice and relaxed. What's the odds against? Drawing a, let's go 4, just because that's part of the last problem. So what's the odds against drawing a 4? And then if you have your notes from last time, I told you about the deck of cards. You need to flip back into that. Or if you're watching the video, open up another tab and Google deck of cards. All right, so again, if you can make the leap, that's great. We're going to end up in the same place, but the probability of failure probably is success. So if success here is drawing a 4, okay, what's the probability I failed to draw a 4? Well, how many non-4 cards are there in the deck of cards? Okay, there's 48 out of 52. That's great. And then I have success. There are 4 4s out of 52. So then I'm just going to go ahead and, yes, once you get good at working with the fractions, this all becomes kind of immaterial. I'm going to do a little more reducing. 48 over 4, 4 goes into 48 and leaves 12. And so the odds are 12 to 1, meaning there are going to be 12 failures for every 1 success. So if somebody keeps putting a deck of cards in your face, which would be a weird thing to do, and you keep drawing one, then for every 12 failures, you're going to have 1 success. That's the ratio. Remember, that's the law of large numbers. Okay, we're talking about as you do things a lot of times, that's where the odds would happen. All right, so I'm going to change this. Okay, this is odds against. I told you there was another odds. There was odds in favor. So with our deck of card example, I want you to find the odds in favor of drawing, let's say, of drawing a picture card. Yes, that's exactly right. Okay, so the odds in favor are the ratio of the successes to failures. So the probability of success, the probability of failure. So if my success is I want to draw a picture card, how many picture cards are there in the deck? 12. Okay. 12 out of 52. And then what's the probability I fail to do this? Nice, good subtraction. And so then I have 12 out of 52 times 52 over 40. The 52s cancel, and then 12, or excuse me, 4 goes into 12 3 times. 4 goes into 40 10 times. So the odds are 3 to 10, meaning there are 3 successes for every 10 failures. And another way to write that would be 3 to 10, like that.
So when you do the first part, when you mentioned that, the percentage of fail and percentage of successes, you're gonna have the whole, like, the part of the whole, like, 52, or like, however many are in a set every time in a fraction.
Yeah, again, I'm going through showing you the probability because you might encounter a problem in your homework where they just give you the probabilities instead of giving you the amount. But once you've done a few of these, you see the pattern that when you're doing it, when you're actually calculating the probabilities, the denominator is going to be the same because it's failure and success in the same sort of thing. Okay, so as was mentioned, you can just forget that and do there are 48 failures to 4 successes and then reduce that fraction there. That is a perfectly legitimate thing to do. Yeah, that's fantastic. No problem at all. Yeah. In fact, here's a good check for you. Okay, since we're mentioning it, and this is going to lead us to our next style of problem. We're going to do one more example of odds, and then we're going to reverse the process and start with odds, and we're going to get probability out of it. But when I look at this, when I take my number of failures and I add it to my number of successes, what do I get? You get the total. You get 52. Yeah, or 52 over 52 is 1. So that is intentional. Because when you do your odds against, you should get everything, because there's only 2 options, right? There's success or failure. There's no third thing that can possibly happen. So that should always add up to the total number of options. Okay, so here's another problem. Let's grab one from the book. Okay, so here is a spinner. Like we talked about last time, and we went on and on about our favorite childhood games that have spinners. And so let's do this. Let's say this spinner again is divided into 4 spaces, and this is what I'm going to have. Let's say that I'm going to have 2 blue spaces. So again, I'm sure you don't have all sorts of different colored pencils or pens, so just put the word blue in those spaces, and then we'll have 1 red one. And then I grab the green marker, so we'll have 1 green one, and then we'll have 1 red one as well. I was going to do 1 red one, I just thought I'd grab that marker. Okay, so there's my spinner. I'm going to spin, or I'm going to throw a dart at the board and assume that it hits there. It's the same sort of problem. And so here's the question: what are the odds against the red space? What are the odds against the red space? Okay, the odds against the red space. So odds against is the probability of failure divided by the probability of success. So the probability that I fail, the probability I land on something other than the red space is 1, 2, 3 out of 4. The probability of success that I do land on the red space is 1 out of 4. And so then, yes, we can cancel the 4s. If you don't mind, I'm just not going to multiply by the reciprocal. They're in the same spot. And so then I'm left with 3 to 1. We okay calculating odds? once you can do probability, this is why I didn't rush into it last time. Once you can do probability, you can do odds. You just got to remember that it's a different ratio. Okay, so I will have a couple odds problems on the test. And I just make sure that you remember that. So then to finish out this section, I'm going to do a problem. I got a problem for you. And then if there's a question about it, let me know. But let's say this, the odds against a certain event, I'm not creative enough this morning to make up an actual event. Okay, the odds against a certain event are 9-2. So what we are going to do is we are going to calculate from that the probability the event happens. Okay, so we're gonna, the odds against are 9-2. We're gonna calculate the probability of the event happens. So I'm just giving you a moment to write that down because I know there's a bunch of words there and I don't want you to get writer's cramp this morning. Hope State Friday today, so we're all kind of in a good mood once we wake up. Okay, so the odds against are 9-2. So I'm just gonna make a fraction out of that, 9-2. So remind me, odds against, the 9 represents what? Failures. And the 2 represents what? Success. Okay, if you remember that ratio, then you're gonna do great. I want to know what's the probability that the event happens. So the probability of success. All right, well, here goes. This is the link between odds and probability. What's the probability of success? Well, according to my odds, how many successes do I have? 2. Out of how many total outcomes? Done.
Oh, wait. 11?
There are 9 failures. There's 2 successes. So what's 9 plus 2? Those are the total number of things that can happen, either failure or success. That's the only options. So that's the nice thing about odds. It's totally bipolar there. There's only 2 things that can possibly happen. All right. So since I've taken and you've taken all the time to write that on the board, this won't take you very long to calculate. Why don't we get the payoff here? What's the probability the event fails to happen? So real quick, we'll write that down. And then I'm going to find another problem so that you have one to do. And then we're going to be done with this section.
How many sections are in this?
8. We're going to do 2 of them today. But you can see they're not, all of them are not super long. Like this one's pretty short, all things considered. We could have done it yesterday, but there was no real need to. Oh, wait till you see the next one. Okay, so the probability, the odds against are 9-2. I want to now find the probability of failure. So according to those odds, how many times is this event going to fail to happen? 9. How many total times? Yes, you caught on. That's great. Out of 11. So I'm just going to, again, I'm not super creative this morning. I'm still kind of half asleep. So I'm going to say the odds in favor of an event are 4 to, let's say, 15. What we're going to do is we're going to calculate ellipsis, then you're going to do both things for me. Since you're writing this down, you might as well do both parts. So what's the probability the event fails to happen? And what's the probability the event does happen? A moment to sort through all that. So the odds in favor are 4 to 15. Since this time the odds are odds in favor, the 4 represents what? Successes, that's great, thank you. And then the 15 represents, yep, appreciate your participation. And so what's the probability of failure? Well, according to the odds, how many failures am I going to experience? 15 out of how many total times? There you go, perfect, you caught on, I love it. Then the probability of successes is just going to be the rest. According to the odds, this is going to succeed 4 times out of the 19, and there we go with it. So before I cut off the video, we move on to the next thing. Is there any question, comment, or concern? Anything about odds that we need to make a little? I was just looking at the homework. Let me mention this one thing for you and for the video. In case your probabilities are given to you, instead of being given as a problem, like we have to calculate, let's say your probability is given as a percent. Okay, so 35% of people do some certain thing, and you got to calculate the odds. What you would do, so if I tell you the probability of success is equal to 35%, okay? You might be given a pie graph or something, or you might be given a chart, and it says the probability of success is 35%. Then we're asked, what are the odds against? Again, I'm not giving you any context for the problem, but you'll get the gist of it here. This is kind of the reason why I kind of drilled into the idea of the odds in favor or the odds against are the probability of something divided by the probability of something. So the odds against are the probability that something fails to happen divided by the probability it succeeds. So the whole point to this problem, can't spell and talk, sorry. The whole point of me doing this is just in case you encounter something with a percent, I don't want you to be thrown for a loop here. So if the probability of something succeeding is 35%, we'll start with the denominator because that's where success is. Does anyone remember how to make a fraction out of 35%? Do you remember, did your teacher, did anyone ever tell you what percent literally means? Right, per means to divide. The prefix or suffix cent, like how many cents are in a dollar? 100. Okay, so it means divide by 100. That's what that word literally means. And somewhere historically, somebody probably just got so lazy and doing that they just wrote a division bar and a couple zeros. That's where the percent symbol came from. Okay, so when you say the probability of success is 35%, that means 35 times out of 100. So there's the quick fraction to make. So if success in this case is 35 out of 100, then how many times are left to fail? Yeah, there you go. Because, and hopefully you're remembering, I said earlier that these two things should add up to our whole, which is 100. So 65 out of 100. And then I'll leave the rest of this to you. It's just reducing some fraction from there, but then you come up with the odds from that. So if you're given a probability in some sort of chart or table as a percent, that's how you deal with it. And I just didn't want you to encounter that and then curse me over the weekend because I didn't do a good job. Anything else?
Is that on the test?
Anything can be on the test. If it's on the homework,